Hello students, your physics teacher Hassan Darwish with you. I'm going to explain this chapter 4, which is about mechanical oscillations for LS and GS students through a series of videos. And this is the first video in which I will make introduction about mechanical oscillations. Let's start with the objectives of the chapter. Now, the first objective, define oscillatory phenomenon and state its characteristics. The second objective, establish the differential equation of simple harmonic motion by applying the principle of conservation of mechanical energy. Distinguish between damped and undamped oscillations. Identify the driven oscillations. Okay? So let's start with the first objective. We recall the following periodic motion from last year or periodic phenomenon. Now, what is periodic motion or periodic phenomenon? Do you remember from last year? Now, a periodic motion is a motion that is repeated identically at successive instants separated by a constant time interval, which is called the period. Okay, I mean a motion that is repeated every constant interval of time. This is called periodic motion or phenomenon. Now let's take this example. The motion of Earth around the Sun occurs every year. So this is a periodic motion with period 1 year because this is one repetition. The pendulum of a wall clock repeats its motion every 2 seconds. So this is a periodic motion with period 2 seconds. Now the frequency of a periodic motion is the number of cycles per unit time. So the number of times repeated within a certain time interval represent the frequency. Okay? So the frequency, as you see, F equal N over T, delta T. So number of oscillations or number of cycles or number of repetition per unit of time, means per a time interval delta T. And it's also 1 over the period. Okay? So time is in second, the frequency becomes in hertz, as you see. Okay, any problem? Now what is oscillations or vibration? Let's take this elastic spring, vertical spring. Now we suspend from this vertical spring a small particle and it is at rest. Now this position of the particle is called equilibrium position. Clear? Because here the sum of forces is 0 and the particle is at rest. Now let's displace this particle slightly downward or upward. What happened to it? So you see it moves up and down. So this motion of up and down around the equilibrium position O is called oscillations or vibrations of the ball. Okay, clear? Now let's take another example. Here we have a swing or simple pendulum where we have here a string and a ball. Now the equilibrium position of the ball, let me call it point O, not C. Okay? Let me call this point O and this point C, as we did in the first figure. Now O represents the equilibrium position of this ball. Why? Because when this ball is vertical here and at rest, the sum of forces is 0 and also the sum of moment is 0. Now we displace it from the equilibrium position like here and leave it. What happened? It makes like a swing, moves back and forth. You see? So the motion of this ball around point O, which is the equilibrium position, is called oscillations or vibration. So what's the definition of oscillation or vibration? According to our observation here in the two pendulums. So when a body moves back and forth between 2 points around the equilibrium position, its motion is said to be oscillations or vibrations. So oscillations or vibrations is a back and forth motion or to and fro motion of a body between 2 points around the equilibrium position. Be careful, around the equilibrium position, okay? Now, the maximum distance or maximum displacement the body can move away from the equilibrium position is called what? Amplitude. I mean, the distance from O to A or from O to B is called amplitude. Okay? Here also amplitude. Similarly, O to A or O to B, if this is B and this is the maximum displacement. Okay? So this is called the amplitude. Remember this from last year and the year before. Okay, fine. Now, mathematical note. In reality, if we want to study mechanical oscillations, we need some mathematics. Okay? Now, what is this mathematics that we need in the studying of mechanical oscillation? I called it mathematical note. Here, let t be a variable and y equal f of t be a function of time. Okay? Like when you say in mathematics, y equal f of x. Sorry. Here, in mathematics, the variable is x, while in physics, the variable is time. Be careful about this. You know this from last year. So y equal f of x. This is a function of x. So because the variable in physics is time, not x, so we use y equal f of t. An equation of the form y double prime plus alpha squared y equal to 0 is called second order differential equation. This is called in mathematics differential equation. Why is this? Because we have the function y and we have its derivative y prime or y double prime. So when the function y and its derivative exist in the same equation, we call this equation differential equation. Okay? Why is this? It's very easy to solve an integral. Okay? But when you have the function y and its derivative y double prime or only y prime, we say we have differential equation in mathematics and it has a special technique to solve in mathematics. Okay, this is not our work in physics. You study this carefully in mathematics. Now, what is alpha? Alpha is a constant. Like when you have, for example, say y double prime plus, for example, 4y equals 0. So alpha is what? Is a 4. Okay? Good. So what happens if we have this differential equation? How do we find the solution? So mathematicians say that the solution of this differential equation is this. The solution of this differential equation is of the form y equal a cosine alpha t plus phi or y equal a sine alpha t plus phi. Or in mathematics, they like to write this form. But in physics, we like to write a cosine alpha t plus phi or a sine. Don't forget that cosine and sine are twins. Means you can always change from cosine into sine or from sine into cosine by adding or subtracting from the angle pi over 2. Now what are A and alpha? A, B here, and phi are arbitrary constants. What do we mean by arbitrary constant? They are constant of integration. Don't forget that when you make integral of a function, if you have y prime, then you get one arbitrary constant. You know this from mathematics, yes? But if you have y double prime in mathematics, you get two constants. Is that true? Say you have y triple prime, you will have three constants. Now because we have here y double prime means we have two constants, two derivatives, sorry, we must obtain two arbitrary constants, A and phi or B and phi, okay? Okay, in physics we will often use this form to find the solution. A cosine alpha t plus phi or A sine alpha t plus phi. Okay, we will skip this for now because you use this in mathematics. But here A and B are the two arbitrary constants. Here A and phi are the two constants of integration. Clear? Okay. So, nature of motion. You know that we studied in first secondary and in second secondary that when the velocity is constant, we get uniform rectilinear motion. And you know also when the acceleration is constant and the trajectory is a straight line, we get uniformly accelerated or decelerated rectilinear motion. You remember this? Okay. So the time equation here, we wrote x equal vt plus x0, if you remember. And the time equation here is x equal half a t squared plus v0 t plus x0. Okay? So, which type of motion do we obtain if the time equation is of this form, containing sine or cosine? So, what do we call this motion? So, here it is. If the time equation of a body is of the form, let me erase here. A sine alpha t plus phi, then, or a cosine, the same, doesn't matter. Then, the motion is said to be simple harmonic motion. Simple harmonic motion, okay? Okay. Next period, and the next, video, we are going to start studying simple harmonic motion or the motion of a horizontal elastic pendulum. That's enough in this video. Take care. Bye-bye.